So now I will explain the complete picture or complete architecture of JVM. Okay, this is in the last session part by part we discussed. Now let me go for one full-fledged diagram. What is so complete architecture of JVM diagram I will explain right now. Listen, sir. First we have .java file is there. First we have .java file is there. Okay. Here in the .java file, of course, my Java program .java file is there. Test.java, Java source file, within bracket .java file. Correct or not? This .java file, my compiler what it's going to do? Okay, Java compiler. If I give Java compiler, of course within bracket Java C command. Correct or not? Java C. This compiler will generate Java class file. Correct or not? Java.class file. Of course, what it means is a .class file I got. Okay. So this is at very beginning stage. Okay, something like, sir, Java source file. If I compile, now .class file is going to generate. This .class file I have to give as input to JVM, Java test. Then JVM is responsible to load and execute test.class file. Okay. Now this one acts as .class file acts as input to class loader subsystem. Have you remembered in the last session we covered JVM architecture with respect to 3 modules. First module class loader subsystem, second module various memory areas, third module is nothing but what? Execution engine or execution unit like. Now here just observe. So here I have one module named with class loader subsystem. Okay, named with the class loader subsystem I have. Okay, here assume this one is class loader subsystem. Like. Okay, in the class loader subsystem mainly there are several parts are there. Okay, first one loading, linking, initialization. Have you remembered, right? What is the first part? Loading. Second part is what? Linking and initialization, right? Even so, the first part, okay, is loading. Now, first part is loading, and what is the next one? Linking. Second part is what? Linking. Third part is what? Initialization. Third part initialization. Total three parts are there. Initialization, right? Okay. Even in the loading, I hope you people may aware, in the loading also there are multiple parts. Once again, bootstrap class loader, extension class loader, application class loader. Yeah, what is the first one? Bootstrap class loader. Second one is what? Extension class loader. Third part is what? Application class loader like. Okay, it is the child of this one, child of this, and it follow which algorithm? Have you remembered? There is one algorithm I covered, extension delegation hierarchy algorithm, right? Okay, this total these 3 modules are by default considered as loading mechanism. Okay, loading. Next and after that, second part is nothing but what? Linking. In the linking, once again 3 phases are there. What is the first one? Verify, prepare, resolve. Sir, first activity. What is the first activity will be performed? Okay, the first activity verify. Second activity prepare. Third activity resolve. Okay, so this one and then this. So now just observe the point well. Okay, like now the third one initialization. Of course it is initialization. initialization, right? Okay, so first this part will be executed and then this one, and after that this one, right? I hope it is clear for all of you, right? So this total thing, who is the responsible? Class loader subsystem is the responsible for this activity, right? Are you getting? Okay, so that's all. What is this component? Class loader subsystem is the responsible for loading, linking, initialization. How many types of class loaders are there? What is the rule of class loader? What is the algorithm followed by class loader? Next, and after the linking, how many activities are there? Initialization, like. So do you know, for this class loader subsystem, which one acts as input? Here this dot class file acts as input for this. That's why here just observe whatever dot class file, so files are there, okay, this one acts as input to class loader subsystem. Are you getting? This one acts as input to class loader subsystem, right? Okay, that's all. Now this class loader subsystem is responsible to load our classes. So while loading, so to load, some memory must be required, and while executing, some memory must be required. So what are various memory areas present inside JVM? Can you explain what are various memory areas present inside JVM? Okay, now here observe this one, observe this part. Okay, what are various memory areas present inside JVM, right? Okay, various memory areas present inside JVM, right? Now various memory areas of JVM, various memory areas of JVM. Now sir, here just this one can communicate with these, right? In that total, how many memory areas are there inside JVM? Can you spell out? 5. What is the first one? Method area, heap area, stack area, PC registers. Last one is native method stacks. Now observe, sir, first part. Okay, first part I am talking about. Okay, this is method area. Assume method area. Do you know, in the method area, which data will be there? Class data will be there. Correct or not? Here class data will be there. In the method area, class data will be there. Class level data will be there. Class level data. I hope this. Now the second one, here do you know, if I consider second memory area, what is the second memory area? Heap memory. Do you know, here the second memory area is heap area, right? In the heap area, which data by default will be saved? Object data. Objects and corresponding instance variables will be saved where? In the heap area only. Object data, like object data by default will be there. Okay, sir, here object data by default will be there, like. I hope you people can aware instance variable. So and the corresponding objects will be stored here. Next, and after the dot class file dumped into method area, of course corresponding static variables also will be saved here. Okay, this is. Now the third one. Okay, now the third one here is, have you observed what is the third memory area? What is the third one? Stack area. Okay, now this one is stack area. In the stack area, I covered for every thread a separate runtime stack will be created. Sir, here this one, do you know, here this is, okay, for a T1. Do you know, this is for a T1, this is for T2, like a T2, like so dot. This one is for what? Tn. Okay, like. I hope you people can aware. So do you know, each entry in the stack is called what? Stack frame. Have you remembered? This one is called a stack frame. And a stack frame once again contain how many parts? 3 parts are there. Local variable array, second one operand stack, third one frame data. Okay, here total 3 parts are there. Every stack frame contain three parts. Local variable array, next frame data, next and after that what? Operand stack. Okay, like total 3 parts are there, like. So for every thread a separate stack will be there. All local variables will be stored where? In the corresponding runtime stack. Clear for all of you, right? Okay, this is, so this one is nothing but what? Stack area, right? Now the fourth memory area. Okay, like fourth memory area is what is the fourth one? Have you remembered? PC registers. Okay, this is fourth one, PC registers, right? Yeah, this one PC registers, like very simple. PC register, this is okay, PC register for thread 1, this is PC register for thread 2, PC register for thread n. Okay, sir, PC register for T1. Are you getting? For thread 1, PC register for T2, next PC register for Tn. Okay, dot, because for every thread a separate PC register will be created, for every thread a separate runtime stack will be created, but for total JVM, one heap area, one method area by default will be there. What is the, can you spell out what is the last part we have to talk? What is the last one? Last memory area, native method stacks. Are you getting this one? Native method stacks. Sir, here for every thread a separate stack by default will be there. So T1 for T1, this is for T2, next dot, this is for Tn. Okay, like, so do you know this is like, this one is like this. I hope not required to keep any explanation now. So this is what? Various memory areas. Are you getting that? Okay, total how many memory areas present inside JVM? How many memory areas are there present inside JVM? Method area, heap area, stack area, PC registers, native method stacks, right? Sir, method area responsible for what? Class level data and static variables will be stored here only. So all objects in Java will be stored where? Is nothing but inside heap area. Next and after that, instance variable is the part of object. That's why instance variables also will be stored in the heap area. Next, do you know? So every array in Java is an object only. So these arrays also will be stored in which memory area? Heap area, right? Next and after that, for every thread, one runtime stack will be created. Each and every method call performed by that thread will be stored in the corresponding stack, including local variables also. Next, each entry in the stack is called what? Stack frame. And each stack frame contain how many parts? 3 parts are there. Local variable array, operand stack, and the frame data. Okay, this part we covered already in the last sessions, right? Next, PC register to hold address of current executing instruction. Once current executing instruction completes, automatically my PC register will be updated to next instruction, right? Okay, this is for every thread a separate next instruction is there. That's why for every thread a separate PC register will be created. Clear, right? And after that, native method stacks for every thread. So this is a separate runtime stack will be created native to hold native method information, right? Is it clear for all of you, right? That's all. These are various memory areas present inside JVM, right? Sir, dot class file came, which is produced by Java compiler. Now the dot class file acts as input to class loader subsystem. Class loader subsystem dumped our dot class file in the method area, like. Now who is responsible to execute our program? Execution engine. Are you getting? Execution engine. Okay, that part we have to talk. Do you know here third part by default considered as execution engine. Okay, like a third part, execution engine, like. Sir, this is execution engine, like. So my JVM can communicate, execution engine can communicate with memory areas. Okay, like, sir, here have you observed in the execution engine mainly two important parts are there. Can you spell out what is the first part? Execution engine contain mainly two parts. What is the first part? Okay, first part is interpreter. Have you remembered? First part is what? Interpreter. Second part is what? JIT compiler. Second part is what? JIT compiler. Have you remembered? JIT compiler, how it is going to work? What are various components are there inside? So the first component, intermediate code generator. What is this one? Intermediate code generator. Okay, like now intermediate code generator produces intermediate code. Okay, intermediate code. Now code optimizer is responsible to optimize that code. Code optimizer is responsible. And then what is the next one? Target code generator. Okay, like this target code generator is the responsible to generate mission code or native code. Mission code or native code, like mission code or native code. Are you getting, sir, this part? I hope. Right? Visible, right? Okay, is it this part? Now listen. So here this part is by default considered as, have you remember in the last somewhere I covered. So in the JIT compiler there is one special component is there responsible for what? Responsible for hotspots. So who is that component? Profiler is the component. Right now. So this is JIT compiler, right? So not only interpreter, JIT compiler, there are several components are there inside execution engine, like garbage collector, security manager, like there are several components are there. This part is what? Execution engine. Okay, now so execution engine is the central component of JVM, just like our CPU or just like our processor. Who is the responsible to do total cinema is nothing but execution engine is the responsible to execute our program line by line. So interpreter and then JIT compiler. With the interpreter there is some problem we are facing. Okay, even though one method we call multiple time, every time interpretation must be required. Instead of that, if it is the repeatedly required method, better to generate mission code directly only once. Next time without interpretation, happily we can execute. JIT compiler is the responsible to do that, to improve performance of the system. Is it clear, right? And then sometimes while executing, okay, while executing Java program, sometimes my execution engine may require native method libraries. That's why, sir, here assume that native method libraries are there. Here native method libraries may be available somewhere in the hard disk or some native method libraries are there. Who is the responsible to provide native method libraries information? Who is the responsible to provide native method libraries information? Yeah, Java native interface is there. Java native interface, within bracket we can use JNI. Okay, is the responsible to provide native method information, right? Now this person can communicate and this person can communicate with that. Now this person is going to provide required information, right? Are you able to understand? Sir, this is so this execution engine is responsible to communicate with, like, so total. So this is simple diagram, the basic idea of JVM architecture, right? Have you remembered? Sir, first I have .java file. My Java compiler is the responsible to compile, to generate .class file, which is nothing but bytecode. Now whenever we are executing, my JVM is going to take .class file as the input. First, who is responsible to load our .class file? Class loader subsystem. Class loader subsystem mainly responsible for how many activities? 3 activities, right? So loading, linking, initialization. Next, in the loading, how many types of loaders are there? How many types of class loaders are there? How many categories are there? 3 types of class loaders. What is the first one? bootstrap class loader, second one extension class loader, third one application class loader. Bootstrap class loader is responsible to load classes from bootstrap class path. Bootstrap class path is nothing but what? rt.jar. Are you getting? All core Java API classes. Which class loader is the responsible to load? Bootstrap class loader is the responsible. Are you getting? All core Java API classes are going to take care by bootstrap class loader. Clear for all of you, right? Okay, this is next one, extension class loader. The class is present inside ext folder, jdk, jrj, lib, ext folder. Extension class loader is going to take care. Application class loader. Application class loader is responsible to load classes from application level class path. Environment variable class path we are going to share. From that is nothing but we are going to get. Sir, can you tell among these the three class loaders, which class path will get highest priority? Bootstrap class loader, bootstrap class path will get highest priority. In the bootstrap class path, if a bootstrap class loader unable to load, then who is going to take care? Extension class loader. If extension class loader also unable to find a dot class file, then what? Application class loader. Are you able to understand? After this loading, immediately verification is going to start. Bytecode verifier is going to verify whether your generated bytecode is proper or not, generated by valid compiler or not. Is it a virus or something like? Who is going to take care is verifier. So if verification fails, then immediately we will get what? Verify error. Are you getting? So Java program is always secured. Happily, blindly you can execute on any machine because bytecode verifier is going to take care is it valid or not. Next one, after that, prepare. Can you tell what the meaning of prepare? Prepare. What the meaning of prepare? So for static variables, memory will be allocated and assigned with default values, only default values, but original values for static variables will be placed where? Inside initialization, right? Next, after completing resolve is nothing but like, so all memory all symbolic references are replaced with original references from method area resolution, right? Initialization, static variable original values will be assigned, static blocks will be executed. That's all. After initialization, class loading completed successfully by class loader subsystem. Are you getting right? Next, how many memory areas are there inside JVM? How many memory areas are there? 5 memory areas. Method area, heap area, next stack area, PC registers, native method stack. In method area, which thing will be there? Class level data including static variables, right? Inside heap area, which thing will be there? Object data and the corresponding instance variables will be there for every thread. Here method area, heap area are per JVM. For every JVM one method area, for every JVM one heap area, but for every thread a separate runtime stack will be there. All local variables will be created where? Inside stack memory. For every method call, one entry will be stored in the stack. Are you getting? That entry is by default considered as what? Stack frame. Each stack frame contain how many parts? 3 parts are there. What is the first one? Local variable array. Related to that method, how many local variables are there and corresponding values will be saved in local variable array. Next and after that, operand stack. If any intermediate operation is required to perform, which one acts as a runtime workspace is nothing but operand stack acts as a workspace. And then frame data, it contains all symbols we used in that method, by default is going to take care. In the case of exception, if any exception occurs, so where the corresponding catch block information by default will be there inside what is this one? Frame data. That's all. Like for every thread, one runtime stack is there. Sir, in JVM 10 threads are executing, then how many stacks are there? 10 stacks are there. Sir, in JVM 10 threads are executing, how many heap areas are there? 1 heap area. How many method areas are there? 1 method area. So heap area, method area is the shared memory for multiple threads. That's why the data which is stored in heap area and method area, so this data is not thread safe because this data can be accessed by multiple threads. But for every thread, a separate runtime stack is there. The data which is stored inside stack memory is always a thread safe because this data is available only for T1. This data is available only for T2 but not for other. So the data which is stored in the stack can be accessed by only one particular thread. That's why this one is nothing but what? So the data which is stored in the stack area is always thread safe. Next, for every thread, one PC register will be created to hold address of next executing instruction. Is it clear for all of you? Right? And after that, to hold native methods information, native method stack by default will be there. That's all. These are various memory area. Programmer point of view, which memory areas are very important? Is nothing but method area, heap area, stack area. The remaining two are dummy with respect to the programmer. Right? More important with respect to the programmer is heap area only, because being object oriented programming language, most of the times in Java we are always talks about what? Objects. That's why, so this area is the very important memory area. Clear? Right? Sir, dot class file loaded. Now, who is the responsible to execute our dot class file? Execution engine. Execution engine contain how many parts? Interpreter, next JIT compiler, and there are some more parts are there. Interpreter is responsible to read, interpret and execute Java program line by line. Sir, if any method repeatedly required, instead of interpreting every time, just compile once into mission code. Next time onwards directly we can use that mission code. Who is the responsible to do this activity? Is JIT compiler, right? So I explained very clearly in the last sessions. JIT compiler, do you know JIT compiler concept applicable only for repeatedly required methods, not for every method. Okay, this is next. And after that, so total Java program should be interpreted at least once. Okay, this is when JIT compiler will come into the picture. If that method is repeatedly required method, who is going to take care whether it is repeatedly required method or not, whether it is hotspot method or not, is nothing but profiler is responsible to identify hotspots. Okay, next. And after that, garbage collector, like there are several components are there. Next, while executing, my execution engine sometimes may require native method information. Who is going to provide that native method information? Java native interface, right? Are you able to get? In the interview room, if any person is asking, can you please explain about JVM architecture, then automatically you can draw this diagram, right? It's very easy. I'm sure you won't ask any other question by seeing this diagram. Okay, like take this one. I hope you completed, right? So that's all. This is a simple architecture. So what we have related to JVM architecture, right? Okay, this, if any person is going to ask, can you please explain about JVM architecture, like at a programmer point of view, up to what level required is like this part. Okay, that's all. Okay, so now the next topic what I have to explain, keep so subheading class file structure. Next subtopic we have to discuss class file structure. Class file structure. Okay, sir, what is class file structure? What we have class file structure? If we open dot class file, so what are various important components are there inside a class file? Okay, this is what things my JVM is going to store from dot class file. Okay, this is just observe here what are various important parts are there regarding class file. Here just have a look once. Here just see this one. This is the class file structure what we have. Here just observe class file. Within the what important components are going to be saved? Magic number. What is the meaning of that? I will explain. Minor version, major version, constant pool count, constant pool array, flags, and this class. What is the fully qualified name of current class? What is the fully qualified name of super class? How many interfaces implemented by current class? Which interfaces? How many fields current class has? What are various fields? How many methods are there? What methods? Next, how many attributes are there? What attributes? Like for every dot class file, JVM is going to save this total information. Of course, JVM is going to save this total information in the method area. Is it clear? Right? First, take this one. Class file structure. Like take this total part as it is, and then I will start explaining the things. Class file, magic number. Next, minor version, major version. Magic number, minor version, major version, constant pool count, constant pool array, access flags like take clearly, and I will explain these are things. Magic number, minor version, major version, constant pool count, constant pool array, access flags, this class, super class, interface count. Take clearly. Interface array, interface count, interface array. Next, fields count, methods count, attributes array. Minor version, major version, constant pool count, constant pool array, access flags like. Can completed, right? Okay. Now sir keep submitting magic number, magic number, magic number. Do you know, sir, I told how the JVM can identify whether the dot class file is valid or not, whether the dot class file is generated by proper compiler or not. Okay, the first 4 bytes in every dot class file should be, so the first 4 bytes in every dot class file should be 0x. Now what is the meaning of 0x? 0x means hexadecimal number. So kf, CAFE, kf babe, BABE babe. You are getting? The first 4 bytes in every dot class file should be 0x kf babe, is nothing but hexadecimal number kf babe. This kf babe is by default considered as magic number, right? Are you getting? Internally JVM bytecode verifier is going to use the first 4 bytes, is it kf babe or not. So if it is a kf babe, is nothing but boss valid dot class file generated by proper compiler only, like sir. So this one is nothing but what? Magic number. Suppose if my JVM unable to identify this one, immediately we will get runtime exception saying class format error, like are you getting? Sir, it's not proper dot class file, that's why I can't execute this one, like immediately we will get runtime exception, right? Are you able to understand, right? Now just observe this one. Yeah, let me execute a small program on here. See, class test I'm taking, system.out.println, okay, hello. So magic number, like I'm taking hello magic number demo, like I'm taking. That's all simple. Class test public static void main and so on, magic number demo. Sir, now let me compile this code. Java C test.java. Compile or not? Yes. So now dot class file generated by compiler, where the dot class file will be saved in the same current working directory. That's why here. So let me open that dot class file. Sir, test dot class. Okay, this is, don't try to read this one, it's a horrible, okay, not in readable form, is nothing but like this is the dot class file. Okay, now the first 4 bytes of this dot class file, okay, 0x kf babe, we can't see, it is not in readable form, it's not. So my JVM can able to understand this one. Now let me here see magic number or something like magic number, you can able to see the word hello magic number, like of course SOP related thing, this is anyway, but the first 4 bytes by default considered as magic number, right? Now see this one, Java test. So is the dot class file generated by valid compiler or not? Yes, that's why we won't face any problem. Happily the code runs fine and the output we are getting, like suppose assume, sir, the first some dot class file part I'm removing, sir, I'm removing some dot class file part. Okay, now is this dot class file generated by valid compiler? No, because I disturbed the dot class file, I removed something from there. Now my JVM always trying to find what the first 4 bytes should be 0x kf babe, but it's not fine, it's not available, it's not matched. That's why immediately my JVM is going to write class format error, something like boss, it's not dot class file, valid dot class file, I can't run, like do you know, just observe Java test. Now have you observed exception in thread main, java.lang.class format error. Are you getting? Java.lang. What? Class format error. Now incompatible magic value. Have you observed incompatible magic value? Which one is the incompatible magic value? 194 something like in class file tester. Is it clear for all of you, right? Okay, this is. So the first 4 bytes in every dot class file should be 0x kf babe, which is also known as what? Magic number. So JVM will use this magic number to identify whether dot class file is generated by proper compiler or not. Clear for all of you, right? Okay, at this point keep submitting magic number. Get the first 4 bytes of the class file, first 4 bytes of the class file is a magic number. The first 4 bytes of a class file is magic number. this is a predefined value. This is a predefined value. This is a predefined value. This is a predefined value used by JVM. Used by JVM to identify. 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 Dot class file is generated by valid compiler or not. Dot class file generated by valid compiler or not. Valid compiler or not. Valid compiler or not. Next, the value should be the value should be what? 0x caf babe. 0x caf babe. The value should be 0x caf babe. Caf babe. CAFE caf babe. BABE babe. Next, take a note. Whenever we are executing a Java class, whenever we are executing a Java class, Java class, whenever we are executing a Java class, if JVM unable to find valid magic number, if JVM unable to find valid magic number, if JVM unable to find valid magic number, then we will get runtime exception. Saying you can see from screen, we'll get runtime exception saying java.lang.da class format error. Java.lang.da class format error colon Java.lang.da class format error colon incompatible magic value. Java.lang.da class format error incompatible magic value. Incompatible magic value. Java.lang.da class format error incompatible magic value. Okay, that's all completed, right? Okay, incompatible magic value. Like, so this is what you people should require to remember. What is magic number? Is it clear for all of you, right? Sir, what is the value of magic number? The value should be 0x caf babe, internally used by JVM to identify whether dot class file is the valid or not. Next, second one, keep submitting. Minor version and a major version. Minor version and a major version. Minor version and a major version. Minor and a major version. Minor version and a major version. Now observe this. This point is also a bit important for you people. Suppose here I have one Java program is there. Here my compiler, I'm using 1.6 version compiler. Compiler is which version? 1.6 version. But my JVM is 1.7 version. Can you tell 1.6 version compiler generated dot class file can be executed by 1.7 version JVM or not? Yes, higher version JVM can provide support for lower version dot class file, no problem at all valid. Suppose here I am taking compiler is 1.7 version. Compiler is 1.7 version, but my JVM is 1.6 version. Can you tell is it going to run or not? No chance at all. Immediately we will get runtime exception saying unsupported version, unsupported class file version exception, something like some exception we are going to get. Some higher version JVM can provide support for lower version compiler generated dot class file, but lower version JVM can't provide support for higher version compiler generated dot class file. Immediately we are going to get unsupported version exception or something like. So this type of experience, I hope this type of thing by default you people can experience it several times. Are you getting? So how my JVM identified that? Sir, this class file generated by 1.6 version compiler, or this class file generated by 1.7 version compiler, by using minor and major versions. Are you getting? In every dot class file, minor and major versions are there. By using that, my JVM can able to identify class file versions. Sir, this dot class file generated by which compiler? 1.6 version, 1.7 version, 1.8 version. How it is going to decide? By using what? Minor and major versions. Minor and major version represent dot class file version. Is it clear? Is it generated by 1.6 or 1.7? Like now we can represent, okay, m dot m. M dot m. Can you tell what is the capital M? What is this M? Capital M means which version? Major version. Capital M, major version. Small m means which version? Minor version. Okay, minor version. The first one major version, second one minor version, right? Now my point is, sir, here take very special care. Major version and minor version. Now the point here is, if it is 1.6 version, if it is the 1.6 version, do you know what is the value? 1.5 version assume. If it is the 1.5 version, my value of major version should be 49. Dot 49 dot 0. Minor version 0, major version is what? 49. Sir, in the dot class file, if I am seeing 49.0 is nothing more, this is a dot class file generated by which compiler? 1.5 version compiler. Sir, 1.6 version compiler 50.0. 1.6 version 50.0. 1.7 version, okay, 51.0. Are you able to get right? 51.0. So this is major version, minor version. Here like same style. So minor and major versions represent dot class file version. JVM will use these versions to identify which version compiler generates the dot class file, right? Is it clear for all of you? Now let me execute this code, or let me consider, let me explain. Here see, suppose I am taking, sir, one here see. Suppose I am taking system.out.println hello major and minor versions demo. Minor versions demo, like I am taking major and minor versions demo. Just one SOP, beyond that nothing. Now here see, sir, I have one command prompt is there. Which version of compiler I am using? Java C -version. Now which version of compiler? 1.7. Sir, Java -version. Which version of compiler? JVM 1.7. Both are same version. That's why I am not facing any problem. So now what I want to do is, let me open another command prompt. Sir, new command prompt. But let me change properties. Font colors like screen text. Okay, blue. Screen text blue I am taking. Okay, like screen text blue. Sir, in the blue what I want to do is 1.6 version, but in the red which version I am using? 1.7. Let me go for C:program files Java JDK 1.6 version bin like. Sir, because I have to set the path. Now blue color, okay, set path is equal to JDK 1.6 version like. Now let me go for my current version. Okay, now observe. Sir, let me cross check. Java C -version. Which version I am using? 1.6 here. Java -version. Which version I am using? 1.6. Sir, blue color screen talks about which version? 1.6. Red color letters talks about 1.7. Now I have one dot class file is there. Okay. Now let me compile by using, here have you observed? Compiler I want to use 1.6 version, but JVM I want to use 1.7 version. Is it going to work or not? Yes, but reverse. Compiler I want to use 1.7, but JVM I will use 1.6 version. Is it going to work or not? No. Let me demonstrate. Here, see this one. Here, sir, I'm taking, sir, 1.6 version compiler, Java C test.java. Now, dot class file generated by which version? 1.6 version. That dot class file I have to run by using 1.7 version, Java test. Okay, like I'm taking. Have you observed? Hello, major and minor versions demo. Like I'm getting proper output. Now let me do reverse. Sir, Java C test.java. Sir, my dot class file generated by which version? 1.7 version. Now let me go for 1.6 version JVM, Java test. 1.6 version. Compiler is 1.7, but JVM is 1.6 immediately. Have you observed? Exception in thread main, java.lang. unsupported class version error test, unsupported major dot minor version 51.0. Sir, 51.0 means which version compiler generated thing? 1.7. Is it clear, right? Okay, this is, sir, how the JVM can identify that? Major and minor versions is nothing but whether this dot class file generated by 1.6 version compiler, 1.7 version compiler, by using this major and minor version. Clear for all of you, right? Okay, at this point, major and minor versions. Okay, add major and minor versions. Major and minor versions represents. Major and minor versions represents dot class file version. Major and minor versions represent dot class file version. Next, JVM will use these versions. JVM will use these versions to identify. JVM will use these versions to identify. JVM will use these versions to identify which version of compiler generates the current dot class file. Which version of compiler generates current dot class file? Which version of compiler generates current dot class file? Okay, take this one. M dot M. Capital M means what? Major version. Small m means what? Minor version. M dot M. Major version, minor version. Next, 1.5 version, 49.0. 1.6 version, 50.0. Next, 1.7 version, 51.0. Like, have you observed, right? Okay, take a note. Lower version compiler generated dot class files. Lower version compiler generated dot class files can be run by. Lower version generated dot class files can be run by higher version JVM. Can be run by higher version JVM. But higher version compiler generated dot class files. Higher version compiler generated dot class files. Can't be run can be run lower version JVMs, can be run by lower version JVMs, can be run by lower version JVMs, lower version JVMs, lower version JVMs. Are you getting the point, right? Okay, this is lower version JVMs. Okay, if we are trying to run, we will get runtime exception saying, okay, you can take from screen. We'll get runtime exception saying unsupported class version error, unsupported class version error, unsupported class version error, unsupported class version error. Okay, like, are you able to get? Okay, this unsupported class version error. Okay, now just take this part, these two things. Java C example, Java C 1.6 but Java 1.7, Java 1.7 next up, but Java C 1.7, Java 1.6 version invalid. Immediately we will get runtime exception saying, what that runtime exception is, unsupported class version error. Unsupported class version error. Unsupported class version error. Class version error. Like, can I hope not required to keep much explanation. Okay, that's all. So there ends what? Magic number and magic number, minor version, major version, remaining parts. Okay, better to consider from screen. Okay, here next, third one, constant pool count. Keep suffering. Constant pool count. Constant pool count. Constant pool count. Yeah, it represents number of constants present in constant pool. It represents number of constants present in constant pool. Presence in constant pool. Next, constant pool array. Constant pool array. Constant pool array. It represents information about. It represents information about. It represents information about. Information about constants present in constant pool. Constants present in constant pool. Information about constants present in constant pool. Constant pool. Next, access flags. Next one, access flags. Access flags. Access flags. It provides information about. It provides information about modifiers. Modifiers which are declared to the class. Which are declared to the class. Which are declared to the class. To the class. Next, this underscore class. This underscore class. This underscore class. It represents fully qualified name of the class. It represents fully qualified name. Fully qualified name of the class. It represents fully qualified name of the class. Fully qualified name of the class. Class. Next, super class. Super class. Super class. It represents fully qualified name of superclass, immediate superclass of current class, immediate superclass of current class. Okay, just observe this one. Sir, this is my test class. This is the test.class file. Okay, like, sir, here this class, this underscore class. Now which one is the this underscore class? Test. This underscore class test. Next super underscore class. Can you tell for the test which one is the super class? Object java.lang object, like. Okay, take this part. Test.class. This class is nothing but text. Super class is object. This class super class. Completed, right? Next, interface count. Next one, interface count. It returns number of interfaces implemented by. It returns number of interfaces implemented by current class. It represents number of interfaces implemented by current class. Current class. Next, interface array. Interface count. Next, interface array. It returns in interfaces information. It represents or return interfaces information implemented by current class. Next, fields count. Okay, it represents number of fields present in the current class. Fields are nothing but static variables. It represents number of fields present in the current class. Next, fields array. It represents fields information present in current class. Fields information present in current class. Fields array. Fields information present in current class. Next, methods count. It represents number of methods present in current class. It represents number of methods present in current class. Next, methods array. It provides information about all methods present in current class. It provides information about all methods present in current class. Next, attributes count. It returns number of attributes present in current class. It returns number of attributes present in current class. present in current class. Next, attributes array. It provides information about all attributes. Present in current class. It provides information about all attributes present in current class. Present in current class. Attribute means instance variable. Field means static variable, right? Okay. Next, here just observe. Here just I'm taking. Here see. Sir, Java C tester.java. Dot class file is there. Now observe. If you want Java P -verbose, okay, followed by tester.class file. And now just I'm taking. Observe. Can you please profile of tester.class? I'm taking. Now do you know? Here just observe this one, the profile complete, at least some area we can able to get. Here see this one. So here last modified date, size 433 bytes, checksum, compiled from tester.java, source file tester.java, minor version 0, major version 51. What is the meaning of this one? Minor version 0, major version 51. What is about this one? 1.7 version. Next flags, next constant pool contains so and so, is nothing but like constants. Do you know java.lang.object, java.lang.system.out, like what are various constants like? So like these are things, which strings are there, extra references, like up to certain level we can able to find. Okay, better to take this command also, java p -verbose tester.class. Java C -verbose, Java P -verbose tester.class. Tester.class. That's all. Completed, right? So this is what you people should aware clearly. Okay. That's all. There ends class file structure. But here only two things are very important. One is magic number. Second one is what? Minor and major versions. Beyond that, remaining things are just a theory. That's all. Okay. So next, JVM architecture and class file structure is nothing but this is the summary, right? Okay. Like.